In the final part of Module 2, we focus on pipelines. Pipelines in Scikit-Learn streamline the process of building machine learning workflows by integrating feature engineering, model fitting, and prediction into a single cohesive structure. This ensures that all steps are applied consistently and make the code more modular and easier to maintain. With pipelines, you can effectively chain pre-processing steps such as standardization, polynomial features, and models such as linear regression, simplifying the workflow for training and evaluation. Recall that in this module, we are working with auto MPG dataset, where the goal is to predict MPGs using two input features, horsepower and weight. And one thing that we discussed was this idea of first cleaning data and then using feature engineering. And in this case, feature engineering involved using a standardization, which means that we subtract the mean and then divide by a standard deviation to make sure that different features are in the same scale. And this was necessary because in this case, horsepowers are in the hundreds and weights are in thousands. And if we do not scale this properly, our model may be overly dependent on larger scale features. However, as mentioned earlier on, one issue that we have to be very careful about is that once we want to do data transformation like this one, where we subtract by mean and then divide by standard deviation, we only need to use one set of mu and sigma, meaning that if during the training stage of our machine learning model we find these two values, we need to make sure that during the testing stage we also use the same exact values of mu and sigma, and we should not change them anymore. And this can be a problem because once we say fit transform for a data transformation like a standard scaler, then the fit part is going to find new mu and sigma values. And this is something that we can obviously during the training stage fix this problem by just using transform instead of fit transform, as we saw in the previous application of data transformation. But this is something that overall can be problematic because you may forget and we transform the data in a different way, and this can cause a lot of problems. And I do believe we have that example here. So you can see that once we decide previously to use degree 2 polynomial, then we have to use fit transform during the training stage, but then during the testing stage, when you use model.predict, we only use transform. And also, in some cases, you may want to add new data transformation or feature transformation techniques. And it is always important to remember that we replicate what we do for the training stage also into the testing stage. And this can be a lot of problems. In order to solve this issue, one thing that we can use is this pipeline in Scikit-Learn, which chains together multiple data transformations. You can have as many of them as you want, and a final estimator. And we mentioned that since we are mainly working with parametric machine learning models, estimators are basically referring to machine learning models that they have parameters that we have to estimate. In this case, for example, a linear regression model. And therefore, you can see that once we define this pipeline, we really have a machine learning workflow, meaning that we have all these steps built in together. And the way that you can use pipeline, so pipeline is inside the pipeline module. So from sklearn.pipeline, we import pipeline. And then the syntax for this is very simple. You use a list of name and transform tuples. So in order to explain what this means, so let's just put everything together what we have in this slide or in this module. So we start by importing this CSV file, and we know that we have to convert the horsepower column to numerical values because they are not by default numerical. We're gonna drop columns that they have missing values, and then we use the function that was called filter and select features. And this does two things: removes cars with 3 and 5 cylinders, and also it makes sure that we have two input features and also the corresponding output vector for MPGs. But here is the main point I want to show you the way that we can use pipeline. So we use this function, and the input argument to this function is a list because we have these square brackets. And inside this list, we have a chain of data transformations. And you use tuples because we have these square brackets. The first one is the name that we assign. So here you can choose any name you want, but we are saying that the transformation is standard scalar. So we want to do feature scaling here. Then on top of this, we want to do polynomial features to create all the features up to degree 2. And then the last step of a pipeline is the estimator, which is now a machine learning model here, similar to, for example, linear regression. And once we define this pipeline, now you can think of this as your entire workflow, which you can do training to find the parameters of your linear regression model, given these data transformations, and also make predictions. So this is now very simple. Since we know already the degree of polynomial, we only do one train test split. We do not need to use cross-validation anymore because we have already decided that degree 2 is the best degree of polynomial. And we use pipeline.fit on the training data. So that's equivalent to training our model and finding the coefficients of linear regression. And then in order to make predictions, we use pipeline.predict. And since pipeline is very smart, it knows that when we use prediction, when we are in the prediction stage, we should use the same exact parameters that we used before for data transformation, meaning that in the standard scalar, we have to divide the data or subtract the data by mean and divide it by the standard deviation. And when you use .predict, knows that we should not reevaluate them, and we should just use whatever values that we had before to transform the data in the same consistent way as we did during the training stage. And in this case, if I run this again, you see that we get exactly the same result as we got before, where we had to do everything step by step. And you can see that this is not a really good practice here, because if we make some small changes, then we may forget to replicate this or consistently apply this to the testing stage, and that can cause a lot of problems. Whereas a pipeline, it's really a workflow where everything chained together. And now if we just want to add like some other like transformation here, I can simply add this here.